Okay, hi, this is Professor Harvey. So I'm going to try to go through this and just hit the high points. We cover a fair amount of this in class, so we're just going to try to sort of hit the highlights here. Kind of recover some of these things. So we're talking about access management, access control, which really is about granting or denying approval to use resources. It talks about physical access control and other things, but we're primarily interested in access to information systems, programs, that sort of thing. So identification is sort of a person making a claim to who they are. Authentication is them proving who they are with some sort of proof, passwords. This really was the subject of the whole last chapter. Authorization is about deciding, okay, so this person is who they said they were. What is that person allowed to access, right? What do they have permission to access or to do on a system? And then the last piece that factors in here that's important is accounting, which is sort of keeping track of what people have done or what you've given them permission to do. So, every time someone logs into the system, it keeps track of that. Every time someone accesses a file, the system should keep track of they accessed a file, they wrote a file, they changed a file, that kind of thing. It keeps track of what they've done. So this is kind of some additional examples of how these things work. So the three key things in any kind of authentication and authorization scenario: the object is the resource that you're trying to access, whether it's a file, a device, a program, a database. The subject is the person who's trying to access the thing. Now, usually a subject is a person, but sometimes the subject is a program, right? A certain program is trying to access a certain file or something like that. So a subject doesn't have to be a person, but normally that's what we're thinking of is a person, a user. And then the operation is the thing they're trying to do. Open a file, read a file, write a file, delete a file, that sort of thing. So these are some examples of specific roles of people who, special roles in the whole process of access control. So key access control models, there are 5: discretionary, mandatory, role-based, rule-based, and attribute-based. This is kind of the core of this chapter. So discretionary means that it's up to someone's just sort of discretion, someone's choice. Basically the way this works is every object has an owner, and the owner has control over who is allowed to access the objects that they control. This is very common in most operating systems, including Microsoft Windows. The problem is it's dependent on the decision of the user who is the owner, and that person may make incorrect decisions. They may not quite understand how the system works. It's very common to go into a place and see that the owner will just grant a high level of access to people who need access, right? So someone comes along to like the manager of, say, the accounting department might be the owner of the folder with all the accounting files in it. And someone comes along and says, oh, I need access to last year's tax documents. So they just give them access to the whole accounting folder. Whereas normally those tax documents will be in a folder that's underneath, right? So you have accounting, you have taxes, and you have taxes like separate folders for each year's taxes, and they might need only access to one of those, but it's common for the manager to see that they just give access to everything, and they might not realize that they can give, say, read-only access and say, okay, this person has access to read the tax files, but not to edit them or delete them. But the owner, they're just an accounting guy, right? They may not realize, that you can give more specific access. So they may just give complete access rather than saying, okay, excuse me, tired, rather than saying, well, we're going to give you access only to read this, which may be preferable. Also, if you give access to a person, to a user, then generally any program they run is going to have access. This is commonly how things get sort of gotten by hackers, right? A hacker gets onto your system and manages to get a program to run under your user ID, and then everything you have access to, now the program that they're running has access to. And this is what this looks like in Windows. If you're the owner of this, this is a PNG file, which is just a picture, right? But you might give access to different people, and you can give different types of access. You see the different types of access here that you can give. Mandatory is the most restrictive model. So discretionary access was the least restrictive model. Mandatory access is the most restrictive, because here nobody really has a choice in what sort of access someone should have. Every object has a classification. It's top secret, it's secret, it's unclassified, and then every user has a clearance level. So users can only access, they have to have at least as high clearance as the classification of the thing they're trying to access, right? So if I'm trying to access something that's secret, if I've got a secret clearance, I can access it. If I got a top secret clearance, I can access it. But if I have a confidential level clearance, I can't access this secret thing. So every single object has a classification label, and every subject has a clearance level. So top secret is higher than secret, and then confidential is lower. Those are the common levels of classification in the U.S. government. And so that's how that works. It's pretty simple. So the object and the subject labels are compared, and the subject must have an equal or greater level in order to access an object. The lattice model is pretty much what we've been talking about there. The Bell-LaPadula introduces another concept, which is so what we've been talking about so far in mandatory access control is the fact that you can't read up. Meaning if I have a secret clearance, I can't read something that's at a higher level, because my clearance only allows me here and lower. So I can read down, but I can't read up. Bell-LaPadula introduces the reverse concept, which is that you can't write down. So if you're on the top secret system, you can't write something down to the secret system. Or in some cases, they even say, hey, if you've got a top secret clearance, you can only write things on this top secret system, because otherwise you might accidentally write something down to the secret system that is top secret. So so those two things on the Bell-LaPadula. So the normal lattice model is just you can't read up. Bell-LaPadula says that's still true, but you also can't write down. That's what Bell-LaPadula is. So Windows has this one form of sort of mandatory integrity control, which is that each user ID, which is the SID is a security identifier. It's a consistent sort of unique numerical ID that's assigned to every user. And the reason that there's a unique numerical ID is because user names can change, but the user that SID will never change for that user. Just like with a driver's license, right? If you have your driver's license, it has your name on it. You get married or something, you change your name for some reason. Your name will change, but your license number, your driver's license number, won't change. It will always stay the same. So a SID is similar, and so the SID has an integrity level. So the integrity level is just it protects the operating system. So most users don't have access to the core files in the operating system. So if a regular user tries to edit a file that's part of the operating system, Windows won't allow it to. User access control is this additional feature. You've probably seen windows like this pop up, or pop-ups like this come up when you're trying to do something on your computer. It says, do you really want to do this? And it's in a window. The reason that this exists is because it prevents someone who is accessing the computer through commands, right? So you know what a command line is, right? It's that the black terminal window where you're typing commands. We've done some of that in the labs. Hackers, illegitimately accessing your system are often issuing commands like that through a text-based interface. They don't have access usually to the desktop with all the icons and stuff and clickable stuff. They don't have a mouse, right? They're just typing commands in. So one of the reasons why this user account control exists is so that if someone is typing commands in, but they don't have access to the graphical user interface here, then they can't click on this. So that hacker will say, oh, hey, I want to access all these files, or I want to add something to the system, and then this will pop up on the desktop. Well, they aren't able to click on it. So that's what that's for. Role-based access control means that the access is based on job functions. So if you're in the accounting department, you have access to the accounting files. If you're in the public relations department, you have access to the public relations files, right? So there's your role in the organization determines your access to different things. So every user is assigned to a role, and the roles are assigned what they have access to. Rule-based is similar, but the difference with rule-based is that it's more flexible. There's more you can add additional rules that say, okay, if someone is a member of the accounting department, then you can add additional rules that say, well, at this time, then members of the accounting department have access to this kind of thing, and just more dynamic roles, right? So it says here that it dynamically assigns roles, and so rather than just a static thing where you assign someone a role and that's their role and that determines what they can access, it allows things to change over time and for you to have different rules that apply at different times to different roles. So it gives you more flexibility. So it's similar to role-based, it just gives you the ability to create more complex systems of rules. Like if this is true and this is true, then allow the person access. And then attribute is even more flexible because it can combine attributes and it can incorporate things like the attributes in the object, the subject, the environment. So it's similar to rule-based. It's just that the rules can have a more complex structure based on time of day, a location. So it's rule-based. It's just rules that have even more options for what can be a part of that rule. So this table is really key. Like I said, this is the heart of this chapter, is these different types of access control. This table is a key thing to check out and to study. So managing access through account management. So account management is the process of setting up accounts, making sure that accounts are kept up to date, that they're shut off when someone leaves the organization. It can also include not just what we're used to thinking of as user accounts, but also service accounts and privileged accounts. Service accounts are accounts that don't really belong to a person, but instead belong to like a system or a program. Sometimes you have a program that runs all the time, like a service. That's what a service is. It runs all the time on a machine, and that service may need to be able to interact with other computers and other machines. So that service is going to have an account. It doesn't belong to a person. That's what I was saying earlier about how subjects are not always people. It might be a service account. Often service accounts are not managed very well in organizations, right? They keep track of their actual users, but the accounts they create for programs to use to access other programs and other systems, they don't have as good a control over them, and they kind of create it once and then they just kind of never think about it again, and those are very commonly abused by hackers. Privileged accounts are accounts that have special access on the system. So usually we think this is an administrator account. On Linux or Unix, it's a root account that has special access and can access more things in the system in terms of changing the configuration on systems. And one key privilege is the ability to add new computers to the network or to add new users is a key privilege. So account setup is a key thing. Every company needs to have a policy for what they do when they set up someone's account. And one of the key things is least privilege. You always want to give someone just enough access to do their job and not access to a whole bunch of stuff that they don't need access to. By giving them the least possible access, that means that if a hacker takes over their account, that hacker will have the least possible access as well. Because employee accounts are often how threat actors get on. Onboarding is the process of bringing a new user on, figuring out what their job duties are. Socializing there, they mean sort of getting them to understand how the office culture works, how the organization works. A lot of companies require special training. They say, oh, you have to take this training course on safe use of the computer before we'll give you an account. So these are some sample steps of what might be included in provisioning an account. Offboarding is the other side of this. This is what you do when users leave. And so they give some sample steps here. What a lot of companies do is this thing about orphaned accounts. They'll leave the account in existence even though the employee is gone. So they'll set that way you can leave the email existing, but you can, a lot of times what they'll do is they'll say, okay, all new emails that come in to this person, send them to their old manager instead, so that if a client tries to email someone who has left the company, you don't want that client's email to just not go anywhere. So you leave the account active and send that email on to the manager so that they can answer it. And then so dormant accounts are accounts that haven't been accessed for a lengthy period. One thing we would often do is run a program to check for accounts that haven't been accessed within a certain amount of time. Like if no one is logged into a certain account within a month, that means maybe that account isn't being used anymore. This is often done as part of auditing, which we'll get to later. So location-based policies, these aren't used all that often, but some organizations might have policies that say where you can log in from, especially with mobile devices. And we talked about that in the mobile chapter. It's good to have standardized naming conventions. Most companies do. So like a small company might use your first initial followed by your last name, like M. Harvey. Larger companies will often use your first name with a dot in between, first name dot last name, Matthew dot Harvey. That's the way mine is at my company. It's also smart, though, to often not use that as a username, but to do something a little more complicated. Like here they say followed by a department code. Better yet, maybe have the username be M. Harvey and then like a 4-digit number that's like at the college. We all have those in our login names. And it's like part of your student ID or your employee ID. That makes it a lot harder for someone outside to guess your username, right? So if someone knows I'm Matthew Harvey, then they may guess, oh, his user account's going to be M. Harvey and try to log in using that username. But if it's M. Harvey 1234, they're not going to guess that. So it makes it a lot harder for someone to figure out how to even try to log into your account. And you can also create time of day restrictions. A lot of types of employees don't need access all the time. So you can restrict what time of day they can log in. So like we said, least privilege, it eliminates unnecessary privileges, right? If someone doesn't need access to, think of it like physical security, right? If you're going to give someone keys to the building, you're only going to give them keys to the rooms they need to get into. That way, if they lose their key ring, then someone finds it, then that person who found their key ring will only have access to a limited number of rooms instead of just giving everybody a master key that lets them into everything. Then if someone finds that key, they can get into everything. So you want to kind of minimize the damage that can be done. There's always a danger in user accounts. You're giving someone access. So you don't want to give them access to more than they need. So auditing is the process of checking on these user accounts. A lot of companies will say, well, we have a process for what we do when we create accounts. We have a process for what we do when people leave. So we know that all of our accounts are what they should be. But the problem is sometimes your rules don't get followed, or sometimes someone forgets to do something. So one thing they would do when I worked for the government is the auditors would come every year. They would go to the Human Resources Department and ask them, give me a list. They would say, hey, give us a list of the last 20 people who left your organization. And then they would take that list of 20 people and they'd bring it to me in the IT department and say, I want to look and see if any of these people's accounts are still active. So then they would look and see if any of those accounts were still active. And sometimes one of them was, sometimes on purpose for some of the reasons we talked about earlier, although usually that account would be sort of still existing but deactivated. Or maybe like we forgot to delete someone's account for some reason when they left. So that's what auditing is. You don't want to just assume the rules are always being followed the way they should. You want to double check on it. Sometimes that auditing, sorry, I kind of skipped one of the parts of this. Sometimes that auditing can also include reviewing their actual access, right? This permission auditing and usage auditing. So permission auditing means, not just checking if accounts have been deleted that should have been deleted, but actually looking at each account and seeing what permissions it has, and seeing if they still should be using those permissions, still need those permissions. The usage auditing means just looking at what have they been using. So you might find, hey, they haven't used a certain privilege or access they have in a long time. Maybe we should just take it away. They obviously don't need it. And it also can be auditing to see if that person's been accessing things that they shouldn't have, or trying to access things that they shouldn't. So best practices for access control, we're going to look at these things here, right? Separation of duties means giving multiple people control over certain processes. One might be creating user accounts, right? Because creating user accounts, if someone wanted to damage a system and they're able to create a user account, they might create a user account for some fake user who doesn't exist, and then they can use that user account to do things they shouldn't be doing, and they won't get caught because it's not them, it's this other account, right? Or maybe reactivate an account of a user who's gone. An example of separation of duties might be making it so that no one person can create an account. One person has to create it, but then a second person has to actually activate it before it can be used. Most often this is done with things like handling money. So a lot of companies will have rules, and sometimes the rules are different depending on how big it is, right? Like the bookkeeper can write checks up to $1,000, but if it's over $1,000, they can write the check, but somebody else has to sign it. And that way, if they can't just steal a bunch of money as easily, it makes it harder for one person to do that. Another way to limit this is through job rotation. What this means is, if it's Joe's job to write all the checks, then after a couple months you have Joe trade jobs with Bob, and now Bob is writing the checks. And so that way Bob might notice there's something weird about this checkbook. There's a whole bunch of money missing, and so you find that Joe's been stealing money all along. By changing the jobs, you're more likely to catch things that aren't being done correctly, fraud that's been going on. And also job rotation is just good for the employees. If jobs are boring, you rotate, you change it every once in a while, so you're doing different things. Mandatory vacations are another way of accomplishing the same thing. Basically you tell people that, hey, you have to take at least one full week off of work every year. And while you're gone on vacation, we're going to have Bob do your job for you while you're gone. And that way you have somebody else coming in and looking at what that person's been doing, because they're doing the same job, and they might catch there's something kind of weird about this. Maybe it's fraud, maybe it's just a mistake or something, someone hasn't been doing it correctly. But having a second person do that job will help you catch those kinds of things. Clean desk policy is more about physically is literally exactly that. You don't want people to just leave a bunch of papers all over their desk, because those papers might have important information on there, and someone walking by can just look at it. What does that say on that desk? Oh, look, it's the list of all of our customers and so on. So sensitive information, really, if you're not sitting there working on it, should be locked up in a cabinet. Is maybe not as important if you have a lock on your door. You can lock your office when you leave, so it's okay to leave stuff out. In high security organizations, they want stuff locked up in the cabinets, even if the office is locked. So it kind of depends. So how to implement access control. Access control lists, this is what gets set on an object. So an object has an access control list that says these users, and these are the subjects that have access to this object and what kind of access they have. So this user has full access, this group has read-only access, and so on. So this is how it works in Windows, is this ACE structure, but it's pretty self-explanatory. Basically, it's just that each user and group, each user and each group has a security identifier, like we talked about earlier, a SID, and that ACE is the method by which they check the SID against the access control list on that object. The interesting thing here is about inheritance. Normally, objects will inherit permissions from a higher object. So in other words, like in my personal computer files, I have my documents, and then I have a folder inside of documents for financial documents, and I have another folder inside of that for tax information. And then inside the tax folder, I have a separate folder for 2018, 2017, 2016, and so on. Normally, objects inherit permissions from higher level objects. So if I gave someone access to the documents folder, they'd be able to read the finance folder, the taxes folder, and each of the ones underneath. But, like it says here, you can create a flag that says, no, the taxes folder doesn't inherit permissions. If you haven't been given access specifically to the taxes folder, then you don't have access to it. Even if you have access to the financial documents, you don't have access to the taxes if you set a flag that says so. So the flags means you can say, does it or does it not inherit permissions from the folder above. So group-based access control, normally the best way to give access to things in Windows is to give access to groups and then put users in groups. So that makes it a lot easier to check someone's access because you can just see what groups they're a member of and not have to look at every object on the system to see what they have access to. If you never give a person by name access to anything on the system, then you know that you only ever have to look at what groups a person is a member of to see what they have access to. In Windows, you can also apply policies based on groups, but using what's called group policy. And this is things like a policy that says how long passwords have to be. Passwords have to be at least 12 characters. You can apply that policy to a group. So like the accounting group, because they have access to more sensitive information, you might have stricter requirements for their passwords. How many times can you enter the password wrong before your account gets locked out? That would be in group policy as well. And it can be different for different groups. In our lab, we talked a little bit about Radius. And so here's Radius and a couple of other services that are used for identity. Radius has been around for quite a while. Remote authentication dial-in user service, like we said, dial-in is really not how it's normally used these days because who does dial-in? There's still a little bit of that in use, but not very much. So the Radius client is generally going to be some device, like maybe a wireless access point, that receives the login attempt and then sends it to the Radius server. So the Radius server is kind of at the middle of the network. And then different devices out on the perimeter of the network receive login requests, validate the login request with Radius, and all these different servers can share. You only have to set a user account once, and it works for everything. Is basically what it does. It centralizes the management of user accounts. At DOJ, I used to have a separate. Every time I set up a new switch, I would have to set up the access control for that switch and set up an account, all the accounts for that switch. But then we got a Radius server. I got a new switch. I just told the switch, hey, validate users against this Radius server, and then it would already be able, then it would look at that Radius server and it would trust that Radius server to validate users for it. So I didn't have to set up new user accounts. It would just use the accounts that already existed on the Radius server. Kerberos is a system that's used. It's used within Windows. Actually, now the newer versions of Windows use Kerberos, and it's basically a ticket-based access system. So when you log in, you are given by the Kerberos server, you're given a ticket, and that ticket, you then show that ticket to some other service that says, hey, I've been given access. Those tickets eventually expire, and you've got to get a new ticket from the Kerberos server. The reason that's important is that you want to make sure that once someone logs into something, they can't just stay logged into it forever, because what if you revoked their permission to that database? Well, if the Kerberos ticket never expires, they would have access to it forever, even after you removed their access, but they still already have a ticket that says they have access. It's kind of like we talked with certificates, right? Like if I give you a driver's license, you want to have an expiration date on that, because if the state of Maryland says, hey, this person, we're going to revoke his driver's license, well, they may not actually be able to go to you and actually get that physical license back, but it's got an expiration date. So eventually you're going to have to go renew it, or it just is no good anymore. So it makes it so that people have to come back and get a new Kerberos ticket to access the service, just like you'd have to go get a new driver's license every so often, or else your old one's no good. TACACS, Terminal Access Control System. Terminal Access Control System. It's very similar to Radius. It's a little bit different. It's actually kind of better than Radius, and it has kind of replaced Radius on a lot of things. One of the reasons is the communication for TACACS is encrypted, unlike with Radius. TACACS is capable of using a Kerberos server for authentication. It can authenticate network devices. I'm not sure why they say no here, because Radius can definitely do that, but TACACS can as well. The other good thing about TACACS is that with Radius, authentication and authorization are really the same thing. So Radius says, hey, you've authenticated, so you have access, and it's just you have access. Whereas TACACS says, okay, you've authenticated, now what does he have, what is he authorized to access now that I've authenticated him? So it's more flexible, and you can set up authorization rules using TACACS. LDAP is really more about identity than anything else. It's primarily a directory service. So Windows has an LDAP-based directory. It's called Active Directory, that stores all the information about the users. What's the username? What's their where are they? Where do they sit? What's their office number? Their phone number? Their email address? You can store all those things in LDAP. It's it's primarily about storing information. So usually you're going to use LDAP to store the user's information, and then some other protocol like Kerberos to actually do the authentication. LDAP can be transmitted over SSL or TLS so that it's encrypted. But LDAP is vulnerable sometimes to injection attacks, with users kind of or attackers kind of abusing LDAP to look things up or try to alter the directory. Okay, so the last thing in this is SAML. SAML is an XML-based standard for security assertions, right? Security assertion markup language. So SAML is usually used for communication between different services, primarily sort of web-based or out on the internet. If you're like me, you sometimes don't like to sign up for new things on the internet. Like you go to a new site, you say, oh, this is a really cool site, and it says, oh, to access this site though, you've got to create an account. And I think, oh, I don't want to create an account for one more thing. I got to create a new username and a password, and validate my email address to this new service. I say, I'm just not going to deal with that. So you may have noticed that a lot of services these days, when you go there, it says, hey, you can create a new account on our site, or you can just log into our site using your Facebook account or using your Gmail account. And SAML is how that works. With SAML, that new service can make an assertion to Google saying, hey, a person with this username at Gmail is trying to log into my service, and it passes along the password or the fact that you're trying to log in. What you log in, you authenticate to Gmail or Facebook, whichever is the service that's, or OAuth is another one that is used for this. That's really all OAuth does, is authenticate people for other services. But basically you say, hey, I want to log in here to your service. That service passes your authentication request on to Gmail or Facebook or whoever the authentication provider is. They authenticate you, and then they make a SAML assertion. They give you some sort of token that says, yes, this person really did correctly log in, and that gets sent along to the service that you were originally trying to log into. Hopefully that makes sense. But it's how that function works, where you can use your Facebook account to log into some other website. Not just Facebook, but other accounts as well. So you see what happens here, right? This is who. There we go. If you look at the order of things, right, the user is attempting to reach this service provider. The service provider generates a SAML request, which redirects the user to the identity provider, right? So this might, like, say you're trying to, you want to log in to CNN, but you don't want to have to create a new account. So you tell CNN, hey, I'm going to use. CNN says, hey, you can use your Gmail account to log into CNN. So it will redirect you to Gmail. You log into Gmail. Your SAML response is created by Gmail saying that you successfully logged in. It sends that to you. You pass it along to the original service provider, and this is cryptographically signed, which proves that Gmail really, you know how we talked about signing and non-repudiation? So since this request is signed using Gmail's Gmail's private key, the service provider can use Gmail's public key to decrypt it and prove that you really did log in successfully. So it's a way that a service provider can trust an identity provider to provide authentication and identification services for them, so you don't have to do it yourself. These are some authentication protocols. EAP is basically a framework. It's not a specific authentication protocol in itself. It's a framework for how other authentication protocols can be handled, right? So these are some older things that used to be used: password authentication protocol, and then challenge handshake. So in order, it's really PAP is the oldest, then CHAP, then MS-CHAP is sort of Microsoft's special Microsoft version of CHAP. I was saying that the other day in class how Microsoft and some of those other big companies tend to make their own versions of protocols. So in EAP, you have a request and the response, and that gives a success or failure message for login. And then here's the summary, and I'm not going to go through the summary because we saw the whole thing, or I mean, we've got this whole video about it. So hopefully that helps you to understand the material here in the access control chapter, and I will see you on Tuesday.